Hello, good day. This is Pazemek from Q9RQ. For many years, I searched for the right system to manage my station until I finally came across the K1XM page, which created an excellent system, which is MOAS, mother of all switches. Last year, we conducted numerous tests and slightly modified the construction of the system. A system was created, which is composed of modules. The first of these is the inhibit module, used to block the transmitter outputs. The next one is the processor module along with PTT signal inputs. Then there are the output modules. Each module has 16 outputs. The maximum number of modules that we can attach to a single processor is 4 units. In total, in such a set, we gain 64 independent outputs. There is the possibility of using several such sets at the same time. Assuming that we have 64 such sets, each with 64 outputs, which gives us just over 4,000 outputs, I think that at each station, this will be a sufficient amount. I would like to present each of these modules to you. Let's start with the first processor module. On the left side, there is a DB9 socket for connecting the inhibit module. On the right side, there is a second DB9 socket for connecting the output module. On the top edge, you will find a USB Type-C port for communication with a computer and a standard power socket for connecting a plus 12 volts voltage. On the lower edge, you will find RCA sockets used to deliver PTT signals from the radio. There is a possibility to connect up to 6 radios, or with the help of a jumper, you can duplicate each of the PTT inputs, which will give you a total of 3 independent PTT signals, each on 2 sockets. The next module is the output module. On the upper edge, you will find the first 8 outputs. On the lower edge, the outputs from the 9th to the 16th. The left DB9 socket is connected to the processor module or the previous output module, while the right DB9 socket is used to connect additional output modules. The activation of each individual output is indicated by an LED located right next to the output terminals. There is a possibility to connect external voltage independently for the upper 8 outputs and the lower 8 outputs. The choice of which voltage we use, whether internal 12 volts or external connected to the terminals, is made using a jumper. The last module, namely the inhibit module, is used to block the transmitter. We have 6 independent RCA sockets. We can configure them in any way in our server script. Our modules are equipped with DIN rail mounts, which allows them to be easily installed in a control cabinet, on a wall, or under a desk. The use of the presented set gives you the ability to control 64 independent outputs, receive a maximum of 6 PTT signals, and block 6 independent transmitters. Let me show you how it works in practice. The server script is configured in a text file. The first section of the server file is responsible for configuring the names of the antennas and the frequency range on which they operate. The next section is responsible for referencing the elements already defined above, assigning them abbreviated names, assigning them conflicts, assigning them the ability for quick switching, assigning them specific frequency ranges and outputs, which are to be activated when selecting a given antenna through the first, second, and subsequent radio. In the next section, we define additional functions, such as activating the relay during transmission, activating the receiving antenna during reception, and other additional functions. The next section is the layout, where we define which antennas should be displayed in the client application for specific frequency ranges for particular stations. Subsequent sections allow for the configuration of shared antennas, the configuration of stacked antennas, and other functions operating with antenna groups. The penultimate section is the configuration of signals from specific radio stations. It refers, among other things, to off-band operation, and it refers to inhibit and PTT signals. The last section is the section where you define the COM ports to which your processors are connected. And now let's move on to pure practice. We already have the robbing program running. The next thing we need is to start the server application. We load the file we just configured into the server application. We receive information on whether our controllers have been connected to the server. If they are connected, we should launch the client applications. In my case, these are already defined as two windows for the first and second radio. The configuration is done in the above window. The first tab is Network, where communication with the server must be configured. The next tabs are Logging Program tabs, where you configure additional radios. On one computer, we run one client. We have the possibility of up to 2 radios, whereas each of these 2 radios can be defined on one of the stations, and on each station we have the possibility of configuring several radios. We communicate with the logging program using the given address and port. The next section is the antenna selector section. Let's check what we have defined for the first radio. For the first radio, we have defined names. We have defined which station it is, which radio it is. We have attached buttons for transmitting and receiving antennas. We have defined the number of rows and columns, and all possible colors. If we have everything configured, we confirm and proceed to the configuration of the logging program. In the Broadcast Data tab, we select the radio to transmit information about the frequency we are currently working on. At this moment, we have the 160-meter and 40-meter bands running. For the 160-meter band, we have defined only one antenna, which is vertical, whereas we have defined 4 receiving antennas. Let's assume they are beverage antennas in 4 directions. The upper part of the button is grayed out because these antennas cannot function as transmitting antennas. However, the lower part of the button is accessible, so we can switch the receiving section. As we can see, the red color indicates which antenna is intended for transmission and which antenna is intended for reception. In the top left corner, we have the amplifier button. By pressing this button when PTT is pressed on the radio, the output is activated, which turns on the amplifier. There is also a coffee button defined, which is used, for example, to turn on the coffee machine. For the 40-meter band, we have 2 antennas available, 3 elements for North America and 2 elements for Japan. We can choose one of these antennas, but we can also transmit on 3 elements and listen on 2 elements. We also have an amplifier button, and we also have a request for coffee. At the moment, when we change the second radio to the 80-meter band, we have 2 antennas at our disposal, a vertical and a dipole. The vertical antenna is currently unavailable because it is being used by the 160-meter band. Of course, we can also use beverage-type receiving antennas. Since the station has a very simple system for switching receiving antennas, radio number 1 only has access to the same antenna that is on the second radio. So we can listen on both radios on the beverage, but in the same direction. At the moment of changing the frequency on the first radio to 20 meters, we gain access to both the vertical and the dipole on 3.5. On the 20-meter band, we have 3 antennas defined: the upper antenna, the lower antenna, and some multiplier antenna towards Brazil. In this case, we also have additional keys for ready-made configurations defined. By clicking the Stack button, 2 antennas are stacked, the upper and the lower. By clicking the Top plus Topojanki button, the top and multiplier antennas are stacked, respectively, the bottom and multiplier and all 3. On the 15-meter band, we also have 3 antennas available, the upper, lower, and multiplier. However, these antennas can only operate in single mode. Of course, it is possible to listen on an antenna other than the transmitting antenna. In the case of the 20-meter band, we can transmit on the stack and listen on all antennas. When changing the band to 10 meters, we also have 3 antennas at our disposal: the upper, lower and multiplier antenna. In this case, the selection of these antennas is configured slightly differently. By clicking on an additional antenna, we have the possibility of stacking. Of course, we have the option to transmit only on the upper and lower antennas, and listen on all antennas or vice versa. It depends solely on how we define it in our server script. If you have any additional questions, I invite you to contact us through our website so9.com, where you will also find a lot of information about the MOAS system and other products. If you want to find out more yourself, I invite you to visit the website k1xn.org, where you will find the program and instructions for the MOAS system. There is a main instruction and a client application instruction. You will find all the information on how to set the buttons, how to color them, how to configure the application together with the logging program. While in the main manual, you will find all the basic information about using this system, about writing scripts, about function definitions, and other aspects of this system. I sincerely thank you for today.